Hi, I'm Darren with Quality News Network, where I only talk about quality and the skilled trades in heavy industry, giving you the information to get recognized and promoted. Today I'm talking about a recurring challenge encountered on small to large mega construction projects: the acceptance criteria for NFPA carbon steel pipe welding, both in the shop and the field. And later, a bonus topic on coatings of hydrants, monitors, and PIVs. As always, do your own research and ask your employer to provide you with all project documents so you can verify your work is in project compliance. So, a general recap for anyone who is not a welder. First of all, a welder needs a qualified welding procedure, and it must be according to the design code. A welder must be qualified to weld all items according to the design code. Qualified welders must weld within their qualification limitations per their qualification, such as pipe size, base metal, filler metal, direction of travel, position of weld. Also, qualified welders must know the acceptance criteria for the weld. When a welder applies their stencil to the weld, they are indicating both the weld and the welder meets the acceptance criteria per the design code. Also, the QC must know the type and the frequency of inspection, such as visual inspection, X-ray, MT, PT, and then also how often is this inspection completed. So now let's get started with the NFPA welding. Now, welders should ask 4 questions before they make a weld to NFPA design code. Again, welding procedures. Is the welding procedure approved for this NFPA design code? Is your welding procedure through API, ASME, AWS, AWWA? That's a good question. Welder qualifications. What are my welder qualification limitations under NFPA? Filler metal, base metal, thickness, direction of travel. What is the visual acceptance criteria for the welds based upon NFPA design code? What is the tolerance for weld reinforcement, porosity, slag, cold lap, arc strike, lack of fusion? These are all really relevant questions for the welder. And then, what is the NFPA non-destructive testing requirement, such as for X-ray? And the percentage based upon the design code. How often are the welds X-rayed? And the NDE acceptance criteria. So if a weld is X-rayed, how big can each indication be? How much lack of fusion? How much lack of penetration? So this is the big question. So where is NFPA carbon steel pipe weld acceptance criteria? What and where are the welding requirements and the acceptance criteria stated for NFPA welds? There are many NFPA standards to deal with. For example, you have fire water main, sprinklers, and foam systems. The answer must be clear between the contractor and the client, and it is usually not defined. Well, maybe not well defined. Now we have 4 places to look for the answer. Let's review them, then I'll cover each one. The first one is the line list. Every foreman and inspector should have the line list, and perhaps even in the print shack. The second is the NFPA standards, available free of charge online, and there's approximately 56 fire protection standards. The employer should provide this to the foreman and to the QC. The next is the client specifications. Every foreman and inspector should have the client specifications readily available and in the print shack. And number 4 is review the RFI log to see if this subject has already been brought up. If nothing is in the RFI log, then we need to issue an RFI to client engineering department, and they will consult with the authority having jurisdiction for the answer. Now let's review each of them, but first let's look at an example of a medium-sized project to better understand what we are talking about. All right, let's look at an example of a fire water upgrade at a refinery. So here we have an NFPA 15 deluge sprinkler system for some new bullet tanks being installed. Additionally, we have a NFPA 11 foam ring system for above ground storage tank with external floating roof. We have 1 here, and we have 3 more foam rings up here. Now, all of this is connected by the NFPA 24 fire water header system running through the pipe rack, connecting all these systems together. And then we have spec breaks between the NFPA 11 and the 24, and the spec break between the NFPA 15 and the 24. Now, some of this is shop fabricated in sections by contractors or subcontractors by making short flange spools, such as for the NFPA 11 fire foam ring going around the above ground storage tanks. Yet some is field fabricated by contractors, such as the long pipe rack sections for the NFPA 24. And then we have the connections between the 24, 11, and the 15. So it's important to know the various breaks in the NFPA standards between the fire protection systems, so the welders will be aware of their qualifications and the WPSs and PQRs being utilized. Now, if welding was the only consideration, this would probably not be an oversight. However, when we look at the complete project scope of work of all the piping, we also now see the ASME B31.3 piping running throughout the facility. So here you will have normal service, severe cyclic, and category D for weld grading. And then you have the ASME B31.4 pipeline running through here, and that's graded under API 1104. So with the welders moving around throughout the facility doing work on a daily basis, this is where we can run into problems. Now, let's take a look at the different requirements between ASME, AWS, and the different NFPA standards. All right, so let's take a look at a matrix amongst all the most common welding codes that a welder can experience. So first of all, let's talk about ASME B31.3, B31.4, 31.8, and D1.1. Okay, so a lot of this is pretty self-explanatory. I'm just going to hit some highlights here. Here under the WPS and the PQR for B31.4 and 31.8. Mainly the WPS, PQR, and the welder qualification is under API 1104. However, for compressor stations and pump stations inside the fence line, it does give an exception to use ASME Section 9. Okay, over here at B31.3, there's three different weld acceptance criteria. You got normal service, severe cyclic service, and category D. All right. The NDE specified, this here does not refer to pressure testing. Pretty much everyone has pressure testing. This is in reference to X-ray, MT, PT, something other than pressure testing. All right. So let's go over here to NFPA 11. So here under NFPA 11, you can see that it's broken out into field welding and shop welding. All right. So field welding for the WPS and PQR, they refer to AWS B2.1. And for shop welding, it refers you to WPS and PQR for NFPA 13, Section 6.5. Right next to us here, we have NFPA 13, but welding starts over in Section 7.5. So 6.5 does not exist. Also, let me just reiterate, all code, standard, recommended practice, anything you use on your project will be year specific. Your client specification or your contract will specify exactly what year of any code, standard, recommended practice to use, because every year does change. Okay, I'm just using the most recent years up here. All right, down here, continuing with NFPA 11, there's no comment in reference to weld acceptance, the NDE, or the frequency of any NDE. And in fact, all NFPAs do not address NDE or frequency. Again, this does not deal or address reference pressure testing. All right. Next, NFPA 13. We talked about WPS and PQR are both in section 7.5.2.5.1. And then down here in weld acceptance, the two items that I picked up was 7.5.2.4.2, fillet welds equal to pipe wall. And also I found curious, it said full penetration welds not required. Very hard to tell visually how much weld metal is actually holding the pipe together. Very interesting. NFPA 15, sprinkler deluge. ASME Section 9. Okay, that's the same as B31.3. for WPS and PQR. Weld acceptance, we got some good information here. No cracks in complete fusion, no porosity greater than a 1/16 of an inch, and no undercut greater than a 1/32 of an inch, and reinforcement no greater than 332. Again, no NDE specified or frequency. And then NFPA 24, which is the great majority of work I find on the projects that I've been on. Again, NFPA 24 does not address WPS PQR, WPQ, weld acceptance, NDE, or NDE frequency. Neither for HDPE or carbon steel pipe. Okay, again, that would come under your client specification, and it also NFPA refers or uses the phrase authority having jurisdiction quite a bit. So anyways, just to reiterate, make sure all the welders are well familiar that their WPS and PQR are in alignment with the work that they are doing. Whether you're working at a petrochemical plant, power plant, processing facility, or any place you're welding pipes, all of these different NFPAs and ASMEs, AWSs will have different spec breaks. Make sure you know where your spec break's at to ensure that you're in alignment, and raise the awareness between all these different codes and all the different spec breaks, preferably in advance, and gain alignment between the contractor and the client, who will have the authority having jurisdiction on the many welding and NDE requirements of your project. Get these all ironed out well in advance so they don't catch you at the end of the job. All right, let's carry on. All right, so let's look at the resource so that you can validate for your project what are the NFPA requirements. So if you go to nfpa.org, click right here, and now you're going to come to here for professionals and list of codes and standards. Click on that right there. Here's more information about free access. To get free access, you're just going to need to provide your email address and then create a password. Down here in fire protection systems, it's showing that there's 56 standards on that. Click here. And here's the most common ones that I've been using myself is NFPA 11. You got NFPA 13. You got NFPA 15 right here. And then next one is NFPA 24. So you click there. Next, for your specific project, you need to pick the specific year of issue for the NFPA. Your client specifications or your contract will identify what year to use, as with all code, standard, and recommended practices. So whatever is applicable to your project, pick the appropriate year. Just as an example, I'm going to use 2022, select edition, and free access. And here we go. And then you come through, click whatever chapter you want to talk about. At the bottom, you can scroll the pages. At the bottom left and at the bottom right, there's a plus or minus. But go through and get familiar with your NFPA. All right, so let's carry on. All right, so the first item that we're going to review is the line list. So again, you should have total access to the line list to validate the design code. So on the line list, if you have the electronic form, put some filters in here, come in here and just sort out all of your NFPAs. Now, if there is a dual design code, it'll be listed here. Sometimes it'll say NFPA 13/ASME B313. If that is the case, and then our work is done, we know that we can inspect welds and conduct testing according to ASME B313. However, if there's only a single item here under NFPA, then this is of no help. Next, we're going to discuss the client specifications. So here's a listing of typical client specifications that I encounter from project to project, covering mechanical, obviously NFPA, electrical and instrumentation, civil, coatings, fireproof insulation, structural steel, and quality control. So under NFPA, you have client specification for the installation, the hydrostatic testing, and NFPA piping material classification. So this is more geared towards the environment and the materials that they require for this particular client. All right, so now let's go over here and look at some additional information. So here are codes, standards, and recommended practices that are typically incorporated into the client specifications. And again, here, anything that's incorporated here by reference, usually on the second page of the client spec, will become part of the client specification. Now, here's time to time I do find ASME Section 9 incorporated into the client specification for their NFPA. Now, this here, if it is incorporated, this would take care of the WPS and the PQR, as well as the WPQ. However, traditionally, I've been finding this more in reference to the HDPE bonder qualifications. However, we can still use it for qualification of steel pipe welders, WPS, PQRs, and WPQs. However, it still does not answer the question of weld inspection criteria and any NDE type and the percentage, and obviously any progressive sampling of rejected welds. Okay, so look in your client specs and see if there's any answers there. Okay, so finally, if you didn't find anything, we have to review the RFI log to see if someone has already asked a question. If you do not find any relevant information in the RFI log, then we'll have to issue an RFI to get a disposition from the client engineering. So if you have never seen an RFI, this is just a boilerplate, typical generic RFI. Fill out everything self-explanatory here on the top. Impact, this wouldn't be relevant, I don't believe. But here you write your issue, no fluff, just right to the point. Ask the question, how do you qualify welders, and what is the weld acceptance criteria and any NDE for NFPA welds? Proposed solution, you can put down weld NFPA piping according to ASME 31.3. And then final resolution, this is where the client engineering will give you their answer. And the bottom is where the client signs and makes it a fully executed document. Now, all of this should have been addressed during the bid process for the project, but again, quite often this is missed and it's overlooked. As a foreman, a welder, or an inspector, ask to see the project documents that establish the acceptance criteria for the visual inspection and NDE requirements for the carbon steel NFPA pipe welds. Identifying this oversight will show your managers your value as a future leader. Also, a weld log that shows a weld as visually inspected with no established acceptance criteria has a really bad look to the client and to the contractor. Now, let's briefly talk about the coatings on newly purchased NFPA items, such as fire hydrants, fire monitors, and post-indicating valves. Now, heavy industrial clients can have specific coating requirements for these items, such as FBE or epoxy, which is much different than the standard vendor enamel coating. And this is usually missed by procurement, purchasing, and receiving. This client-specified coating will be identified in the client specification. Also, as an example, take a dry film thickness reading of a fire hydrant or a PIV and compare it to the dry film thickness of a project pipe paint. And then also, just out of for humor, compare the dry film thickness reading of the fire hydrant to your work vehicle paint thickness. You'll notice that the paint thickness of the fire hydrant or PIV is closer to the vehicle dry film thickness than it is to any of the project pipes. Now, the wrong coatings can make the contractor look bad for ordering, accepting, and installing this product with the wrong coating. So read your client specifications carefully and identify if there's any special coatings, and if so, identify if this is a problem early before final closeout. Be sure to join me on Patreon for more in-depth discussions on subjects like this. Thank you.